Let me introduce myself. My name is Karin Nahon. I'm a professor. I'm an information scientist at the Interdisciplinary Center Herzliya. And I'm also the president of the Internet Association in Israel. And I do education for a living, but I don't research education. But I do research politics of information. I do research ramifications and applications of AI, autonomous or semi-autonomous intelligence systems, and how they impact our lives on a societal level, on a macro level. And so I'm looking at large-scale different systems of AI. That's part of what I do. So let me start with my vision about how I see AI in terms of democracy and in terms of societal kind of ecosystem. I think we have the opportunity, this is really one of the only occasion of opportunities to think deeply about how we design those systems carefully. We're at the stage where AI is already being displayed or being applied in different industries. In education, this is only the beginning. We are only now at the piloting phase. I don't know of many different applications of large scale that have been implemented successfully anyway in education. We are still learning. We're in a trial and error, which is great. But this is the only time that we can really use this time to learn from our colleagues, to learn from other AI industries that have introduced different large-scale systems and what has happened because of that. Not because we want to go back, not because we want to stop innovation, not because we want to be slower with the pace of how we progress with AI, but because we want to be fully aware of the ramification and implication of what we do. And there are many, especially when it comes to education. So let me tell you a little bit of few. So obviously the values I don't need to tell you. AI has a lot of values with adaptive learning, with personalization of the whole experience. It's less of what I want to talk about. What I want to talk about is when we design AI systems, we have to be very careful of the situation where we have, for example, and we usually do have, and I'll give you some example, of bias of data. So I'm a big data scientist, and I see this bias every day. So for example, we had a Google presenter before, like a few minutes before, and he talked nicely about a particular AI system. But let me talk to you about Google Translator, for example. When you translate something from English to Hebrew, and so certain kinds of professions that appear in English as non-gendered, I would say, specific, in Hebrew, suddenly they become gendered specific. So if you're an engineer, you would become a male engineer in the translation to Hebrew. If you are a manager, a director, guess what? You would become a male director and manager. Now, obviously, the engineer would say this is a bias of the data because most of the people that looked for this, they clicked on the male or masculine kind of result that they saw, and the AI system learned it. But so we have to be very careful when we talk about AI system, and we have to think about them carefully, to think about the bias of data and the bias of algorithm and what happens with that, and also the opacity of algorithm. Most of the systems that are being developed today are systems of private organizations, big organizations. In order to develop AI, you need to have a lot of money. I don't have to tell you. And those organizations usually are very opaque to us, the public, are very opaque to us teachers, are very opaque to us, the students. So we have to think when we are getting into large-scale systems in education, we have to think, how do we make the system more transparent? How do we make sure that whatever is being built right now, and this is the time to build those things, is built in the right way, in a way that we, the educators, have a say and a way to intervene if something goes wrong, if the system doesn't go in the right direction. And the reason why I'm saying that, because there are two biases that I'm really concerned about. So the impact of all the biases that I talked about results in two biases. One is allocation of resources. Eventually, the education system is all based on allocating resources, whether it's money, whether it's books, whether it's anything that you can name it and you know about it in the education system. What if those systems would decide who is ranked in what particular way and who is deserving a certain kind of resources? That's okay. Can we, the public, monitor that? Can we know that this is the right process? Can a student that failed the system or failed the different AI exams would be able to go back and say, I need to appeal, something is wrong here? Who would take the responsibility then? Probably the engineers won't know to take responsibility because you have so many indicators, and by that time, the AI system will go far away and will learn with the data that it has, with the deep learning or whatever algorithm that it's using, and will go very far away from where it is. So even the engineer who built it won't be able to tell us why a particular result came this way or not this way. So what I'm telling you is that we are in the right moment of time where the big scale systems are entering into the business of education, and we already have a lot of examples of things that can go wrong with that. And we don't want to go wrong when it comes to our education and to our children, and not only to our children, to each one that wants to learn something in this world. So with this introduction, I hope that we will have a very inspiring two-session. Let me first introduce the first guest lecturer, Yishai Frankel. So I started with talking about large-scale AI versus narrow AI. To whoever is not in the business, narrow AI talks about a specific task versus broad AI that can do many tasks and not only a specific one. Do we care about that? How does that, can you tell us what's the gap between narrow and broad AI? Where are we standing in that state, and why do we care?
Sure. So, as you said, Corinne, narrow AI is AI aimed at a specific domain, a specific problem, whereas general AI, wide AI, is, I would almost say, human-like AI. I think in the popular culture, we are exposed to it continuously, be it movies, books, the rise of the robots, machine intelligence, overtaking, human intelligence, and so on. Now, we know, and this is the amazing revolution we've seen in the past, I would say 5 or 6 years, where narrow AI is starting to solve real-life problems. It's been a promise for over 50 years. It's becoming real, and it's exploding all over us. The number of times AI was mentioned here is scores of times. Now, how far are we from general AI? Or a different term would be singularity, I think, also used in popular culture. It's a big question. I must apologize, I'm not even a doctor, even though it says here that I am. Many, many smart people have discussed, have argued this. I would say my humble opinion is I think we are many, many years away from general AI. Let me just give a small example. In the world of computer vision, which is the place where we see, I think, the biggest explosion, the nicest results, perhaps the most amazing one is autonomous driving. When we try to analyze the process of vision, I think we have 3 steps. One is we need a sensor. We need to be able to discern, to identify pixels, which are dark, which are bright. Once we pass that stage, which, by the way, technologically is fairly easy, comes the identification, okay? This is a ball, that is a cat, here is a human being. And the biggest advances we've seen in the past years have been around identifying, around pattern recognition. But then comes the 3rd stage, which is understanding, okay? This is a ball, great, it's a ball. But what is this ball? Is it a pumpkin? Is it a soccer ball? Is it, by the way, if I'm an autonomous car, is there a child behind that ball? And while we've seen amazing results in being able to identify patterns, be it in vision, be it in speech, and we've seen some examples, I think we are still very, very far away from understanding the full context of things.
Let me ask you a question. Where do you find the most critical role of AI in the education system? So if you had to pick your bet.
So I would, it's being asked, and of course this is the focus of this day, I would look at 2 different things, the what and the how. When I talk about how does AI, how do advances in technology serve the educational system? How could we advance teaching methodologies? And the answer is there are many ways, right? It started years back with LMSs. We see more and more people doing rule-based, personalized teaching. So the how is one thing. But again, in my opinion, the bigger question is what? What do we need to teach the children in this age, in this machine age, in this age of AI? This is going to be an age where people will need to learn to work side by side with machines. People no longer are going to be alone. In my work team, which nowadays has 5 or 6 people, 10 years from now, I'll have 2 machines who are active team members, okay? The workplace of the future, and I think it's becoming evident, will transform itself every 10 or 15 years. Okay, so if I learned a profession today, I do not know what my profession is going to be 15 years down the road. Hence, as educators, what do we teach our students? And again, AI, what I think the focus is, okay, how do we teach? How do we use Alexa? How do we do this? How do we do that? But the bigger question is, what do we teach them? What are the skills of the future? This is a tremendous question.
Is AI a revolution or an evolution? And is it an important question?
You know, evolution and revolution at the end of the day is just a matter of scale. We are about 250 years right now into this massive industrial age. It started with the steam engines, onto railroads, onto steel and electricity, the internal combustion engine, then the computer, and now the intelligent computer, right? A computer that can learn. So this is a big change, and the world has faced these big changes in the past 250 years. But here's the question that I ask myself, okay? Let's reflect back 150 years ago. Let's look at the carriage driver, okay, in London, okay, 200 years ago. That carriage driver who drove his carriage with the horses 200 years ago was replaced by the railroad, right? What happened to him? He became a factory employee, right? So people were really afraid, hey, what's going to happen? What are all these unemployed people going to do? And the answer is this person, in most cases, found his workplace in a factory. However, what happened to the horse, by the way? What happened to the horse? He became sausages, okay? So the big question facing us is, are we the driver or are we the horse? Now, this is not a funny question, okay? There may be ways, if we can together work on them, which will take humanity to the next step up, and the time that frees up, the professions that disappear will transform into higher entities, into more interesting entities. But we cannot rule out the possibility that we will become the horse, that we will be unemployed, there's going to be less of a future, and we may become sausages. And I think the driver versus sausage, that is the big question.
I remember that metaphor.
Yeah.
If you had to think about the risks, so we talked about one type of risk of finding unemployed, being unemployed. But what is the main risk that you find in implementing AI into the education ecosystem, if you had to think about it? Or in more general, if it's more easy for you to abstract it.
Again, AI is a massive change. In change, like everything, has opportunity and it has threats as well, right? The biggest change, and by the way, similar to the advent of computers, it changes us, right? Once upon a time, 10 or 15 years ago, all of us were able to memorize probably 10 to 20, maybe more phone numbers. We're no longer able to do it. By the way, there's a cognitive skill there that disappeared, okay? Now let's look at AI, right? The most immediate example. I think it is evident that in 5 or 10 years from now, we will no longer need to learn languages, okay? We just heard these demos. We will not need to learn languages, okay? I'm going to speak Hebrew, and a machine will translate it perfectly, okay? 99% of the cases. How does this affect us as human beings?
With a gender difference or without?
Ooh, that's a big question. It's going to change us. Yeah.
Sorry, I had to.
Of course.
I think we're being signed that we are ending this session. Thank you very much.
Thank you very
Yishai.
much, Karin.
It's a pleasure.
Bye.
I would like to start, since all of you have a lot of experience in large scales systems of education, not necessarily AI, by the way, but some of you see the differences. Some of you see I would say, the changes and the transformation that we are seeing from the old school education, the digital school education, to AI school education. Give me in 1 or 2 sentences, each one of you, before we start, how do you see the state of implementing AI systems in the world? Where do you see that state? Hassan, do you want to start? Do we have enough microphones?
Hi, my name is Daisuke Asano. I'm director for Education Service Industry, Ministry of Economy, Trade and Industry. And we have, actually, my ministry, METI, Ministry of Economy, Trade and Industry, has launched a pilot project to change the role of a teacher and the way of teaching and learning in the classroom this summer. Actually, in most of the classroom, Japanese typical classroom, there's a conventional way of teaching and learning is prevailing and common. The role of the teacher is writing all the information and the necessary information on the blackboards for teaching textbooks. And the students learn it and they recite at the exam. And such a very old-fashioned style is dominant in Japanese classroom. So METI Learning Innovation Project is sponsoring over 30 projects from this summer. And one of them is using AI. So our trial, this is a big challenge. In some junior high school in Tokyo, this will start from this week. We introduced an AI-based EdTech application named Cubina into a mathematics classroom to change the way of teaching and learning. Using Cubina, students learn mathematics by themselves, facing their own laptop, right? And sometimes the teacher intervene and support their learning. And the teacher, looking at the real-time data through this Cubina AI-based application, the teacher understands which chapter each student is doing now, and how deeply they understand, and what is the setback point for students. And this application will change the way of teaching and learning and the communication in the classroom. And the aim is enhancing the productivity of learning.
Thank you.
Okay, Telefonica Digital Education provides solutions to governments, companies, and also end users in the different stages of life from K-12. There we mainly train teachers. We have about a platform with more than 700,000 teachers that are being trained in new methodologies, etc. We have a MOOC platform for the Latin American world. We go to governments and provide them with solutions to bring coding to the curriculum, train the teachers, provide the content, etc., project-based learning, etc. And so we've been in the EdTech world for over 20 years. And to be realistic, we're very far from being able to include AI solutions into the educational systems in the sector, the countries in which we are. I mean, we're still talking about adaptive learning. We're talking about blockchain. I mean, lots of technologies are appearing, but the truth is that many governments haven't got their content digitized yet, and the teachers have a whole lot of needs and training just to launch a project-based learning service in their classrooms. So it's incredible and it's great to hear about all that, but it's very far from our reality.
Joycey.
Hi. Nestor has been in the innovation space for the last 20 years, and we've used our research to look at emerging trends, but also to invest in early stage companies, and we run some practical programs. So we've looked at everything from flipped learning to digital education to artificial intelligence. And we recently just started doing some exploration just to scan what are all the AI tools out there that are helping learners, that are helping teachers, and that are helping the education system to respond and to change to different needs. So the big problem that Nestor Education is trying to address is how do we prepare young people for the future that's going to be very different from today? We've heard a lot about AI and automation and how technology is leapfrogging day by day. So from a learner's perspective, there are lots of tools out there that provide personalization and adaptive learning. So we've invested in companies like Cogbook, as well as there are a whole range of other tools like MangaHai that personalizes learning for maths. Now, from a teacher's perspective, it's really about how do you reduce their workload? How do you help them improve their practice? And in that space, there are a bunch of new applications that are coming up. One of the companies that we've invested in is called Third Space Learning, which basically helps kids connect with online tutors all over the world. And using the mass amount of data that they have, they provide real-time feedback to the tutor to improve their practice. So this is really interesting. It's not only helping the learner by connecting them to online tutors, but it's helping teachers improve how they deliver these maths classes. We're also seeing some very interesting things from a system level. So Ofsted is using AI to predict which schools are at risk of failing and how you could support them better. So AI, the key message that I want to send is that rather than starting with the technology and then looking for a problem, let's look for the problems that learners, teachers, and the system faces, and then try and solve that, because we definitely can do that.
When we talked in the break, you told me that your company has been doing a research to know which jobs or skills are going to be out of the business, if we want to talk in the most plain way, because of AI. Can you give us a little bit of hint? Because I think that will connect to Carolina's work.
Sure. So we did a piece of research with Oxford Martin School and Pearson to look at expert insights, but also to use machine learning and to predict what are the jobs that are going to be there in 2035, which is not too far. So a lot of kids who are entering schools now, what are the jobs that they're going to have? So we did this research for both US and UK using the Office of National Statistics data. And we broke down thousands of jobs into their skills categories. So what are the skills, attributes, and knowledge that you will need? And what was interesting is that only 10% of the jobs are going to see an increase in demand. 20% of the jobs are going to see a decrease in demand. But 70% of the jobs have a very uncertain future. So you could say that, we could have told you that. But the interesting thing is, we can change things. The things that have an uncertain future, if we can educate and build the skills, complementary skills that will support somebody who is currently in a call center, for example, or is doing administrative support, we can help them have a better job in the future. So I really recommend that you look at the research. It's available online on Nesta's site. If you just Google Nesta Future of Skills Employment in 2035, you can see the report and the video.
Thank you. And that actually combines our talk in the morning. And when you were telling me, AI for me is, I'm going to shame you a little bit, just a little bit. You say, for me, AI is almost a science fiction. We can't say it, but we can't implement that. And we are preparing and developing skills that AI cannot do. So you're looking at the other side of the fence, of where can we enter into the education where AI can't help us, which is the other side of what we just heard. Can you talk a little bit about that?
Oh, okay, yes. In different sectors, for example, in the K-12, everybody is talking about what are the skills that our children are going to need, as they don't even know what type of jobs they're going to have. So everything that has to do with learnability, creativity, etc. This is great in theory. How do we actually implement this in educational systems? How do we help the teachers to really do that in an interesting, fun way for the children, and really give them the confidence that it doesn't matter if they're going to have to reinvent themselves? I think it's about 7 times what they say, no? The children that leave school now will have to reinvent themselves 7 times along their career. That's a big challenge, but we have to take the fear away, and that's important. Another thing that I read the other day that really impressed me was actually the ATT CEO, Randall Stevenson, I think he's called. And he actually did an analysis of his company. There are about 250,000 employees right now in AT&T. And he analyzed that more than 50% of the jobs in 5 years' time will be completely obsolete. So instead of throwing everybody out, he decided to launch an enormous program of reskilling its employees that is costing them $1 billion, which is, I mean, in corporate e-learning, I've been there for 20 years. I can tell you not many companies spend that type of money in reskilling their employees. But that's something that I find absolutely incredible. And second, it's something that corporations and governments really must understand. We have to reskill our people with the type of jobs that, as you say, as artificial intelligence is coming, what are they not going to be able to do for us to really have some job in the future and really work together with it?
Asano, where do you find the challenges? Because you have a lot of experience with governments. So where would you pinpoint the challenges that stops you from implementing? You're just now launching a pilot, as you said.
And the past, the success in the past has become a kind of inertia in Japanese schools. Japan has been successful after the World War II. In the process of modernization, we experienced such a success, and people believe in that. Japanese education is successful, but today we need that. Everybody, most of the people think that the Japanese education need to change, but the teachers do not think so. They are too much accustomed to the current situation, the way of teaching, their methodology. They believe in too much.
So in Japan, mainly the resistance is a resistance to change that comes from the human capital, from the teacher themselves.
Yeah.
And other type of challenges that you see in implementing? I'm sure that you had a lot of challenges.
Yeah, sure.
It wasn't like that.
Technology, actually, we are in the very, we are in most of the Japanese schools at the just the beginning stage of such EdTech, EdTech application introduction. So most of the students do not have personal computers at school, and most of the school is not connected to the internet. And in such circumstances, it's very hard to use EdTech and AI in Japanese school scenes. So Japanese government need to invest more and more to public education. We hire teachers, but we do not spend enough budget to such technologies.
I have a question. So we talked a little bit about the entrance of implementing AI, but we didn't talk about regulating AI. We didn't talk about what are the parts where we need to regulate it, and who should regulate it? It's a very large question, by the way, right? Because obviously we have multi-stakeholders in the table. We have the governments, we have the companies, we have the students, we have the teachers, we have many stakeholders, and it's becoming more complicated because if AI is the technology that ranks students, that helps us to administer teachers, that helps us to make better the learning process, that does all those things. I'm jumping a little bit ahead, I know. How and when and who should regulate that?
Well, I don't have the answer to that question.
I don't think that I have answers as well, by the way.
But something that is clear is that the debate must be pushed up, and actually one of the things that we are trying to promote is generating that debate through, well, for example, and you're all invited to conferences, large conferences, bringing policymakers, bringing philosophers, bringing ethics experts, technical people, the large companies that are generating this, have everybody really share, and as you were saying, be transparent about what is happening. And for us, it's probably the most important thing, how this is going to be regulated in the future to really protect our children and our society in general.
Sorry, thanks. So, Ernesto, one of the crucial questions that we're trying to address is how do you maximize the benefits of AI while reducing the risks? And the questions around ethics and privacy, who owns the data, do you trust the algorithm? If somebody makes a mistake, whose responsibility is it? We've set up a new center for collective intelligence so that we can combine human and machine intelligence because, as one of the speakers referred to false positives earlier on, you do need to bring the two together. We need to wipe the fear that teachers are going to be replaced by technology. It is technology and teachers working together. Governments, policymakers, experts, product designers, they all need to work together. And I think the key thing is the end user needs to be at the center of this discussion.
And of course,
It's the
of
one
course,
that's-
yeah, government can regulate the development of AI, but I think it's too early. I think it's too early.
Too early.
Yeah, too early. Yes. I think in terms of educational use, the AI is in very, very early stage. Early stage. I mean that what AI can do is very limited now. So it's time to implement and such a basic AI to the classroom. So I think it's too early to regulate it. So I think AI and EdTech can secure the equality and accessibility for all the students to have quality content, quality educational content, wherever they are living in a rural area, wherever they are. So that's why we'd like to implement AI and EdTech into the classroom. So we'd like to, and also again, the AI is at just the beginning stage, early stage. So it's time for a government to support development. It's not time to
It's not time to regulate it, it's time to support it.
Yeah.
Interesting.
Time to support.
We are finishing with an interesting statement. Thank you, everyone. Thank you for joining my living room. And thanks, everyone, for the session.
Okay, so I'm the last segment of this session, and a lot of the things that I want to talk about has actually been spoken about by the previous speaker, so that's kind of a good introduction into what I want to tell you, which is about the relationship between artificial intelligence and its current incarnation, a rather primitive one, and cybersecurity. And I'm going to start with the good, and then I'm going to move you all the way to the dark side of what is yet to come. But I want to start with something also slightly dark, which is a few quotes from individuals that I'm sure we all respect, starting with the late Stephen Hawking. Shortly before he passed away, he made this quote that the development of a full artificial intelligence could spell the end of the human race. Of course, Steve Wozniak, one of the founders of Microsoft, who believed that computers, thank you, better. Computers are going to take, but I need a clicker then. Yes. Computers are going to take over humans. There's no question about it. Here's another visionary person who's shaping our future. Elon Musk believes that AI will be the most likely cause of World War III. And lastly, of course, let's also hear a quote from a politician, Vladimir Putin, and he believes that the country that will lead AI development will be the ruler of the world. So there's still a chance for us in Israel because a lot of AI development is done in Israel. We may, in fact, end up being the ruler of the world and start some wars. It's a great outlook to look. But one way or another, no matter if you believe that or not, one thing is for sure, and that is that everywhere you go, and certainly in this room today, everybody is talking about artificial intelligence. It's not just words, really billions and billions of dollars are being poured today into companies that develop artificial intelligence into whatever product that they're putting out. It's really everywhere that we look. Artificial intelligence, and that was asked here before, is it a revolution or an evolution? I believe it to be a revolution, the next industrial revolution. And we've said that before. The original one, the one from the 18th century, was about replacing muscles with machines. Machines that were stronger, machines that were faster, machines that do not get tired. And when we look at artificial intelligence, it's about replacing human brains with machines. Machines that would have the same type of intelligence and intuition that we have learned to only expect from the human brain. And these machines are capable of a much larger scale, they're faster, they don't get bored, which is a common problem with human beings required to do a task over and over again. They don't take a weekend break. This is what the AI revolution will eventually promise us. And it's, of course, already around us everywhere that we look, not just in the educational sector, every sector that we look at, shopping predictions, image categorization, speech recognition. Wherever we go, we see artificial intelligence, and these are indeed just the tip of the iceberg. Today in the financial sectors, eligibility for a loan, the premium for your car insurance. These are things that are being determined by AI-driven algorithms. And if you go into the medical sector, diagnosis of diseases are now also being assisted by AI algorithm. That will just become more and more, we'll see more and more of that. And in every other part, autonomous cars, education, everywhere you look, artificial intelligence is being introduced, and it begs the question, why now? Because all of these topics that I've mentioned, certainly image recognition, speech recognition, when I was in school, and that's more years than I care to admit, these were the subject of research already back then. And we've seen algorithms, and they were very limited in what they can do, and they would only work under certain very specific circumstances, and they would fail wherever you tried to shift them to a slightly different problem. And all of a sudden, in the last 5 to 6 years, we're seeing a proliferation of artificial intelligence all around us. We're seeing problems that were researched in the academia for decades suddenly being solved, suddenly being addressed in a way that makes them viable in a commercial product. So what's changed? And the fact is that much like in many different technological advancements through the history of human beings, we needed several technologies to finally mature and align at the same simultaneous time. And in the case of artificial intelligence, there are 3 key technologies that have finally reached that maturity, the first of which is storage. A few years ago, it was very expensive to store massive amounts of data. Today, data storage is very accessible to anyone. And the fact that we can store gigantic amounts of data at a fraction of the cost makes it accessible. The second thing that we needed, of course, is compute. Because it's not enough to store this data, we now need the compute power to process these mountains of data. And now we have access, again, in a way that is accessible to individuals that want to start their own company. They can indeed hire enough compute power that will allow them to process these gigantic amounts of data. But these two wouldn't have been enough, and these two have already been progressing over time very much, almost linearly, I would say. There is a third element that has actually made the difference, and that is the mathematics. The mathematics that drives artificial intelligence in its current incarnation, which, as many of the previous speakers mentioned, is kind of primitive. We will definitely look back at it in a few years' time and say, oh, how did we ever think that that was advanced, that was so primitive? Just as we look at our phones from 4 years ago. So the mathematics that drives artificial intelligence today is the result of some breakthroughs that were seen no longer than 5 to 6 years ago. And that has completely transformed what we're doing in this world of AI, and the 3 of these together in a costly way makes the difference between something you can do as a research project and something that you can actually put into a viable commercial product, which is what we're seeing all around us. Okay, so what does it take to have a good artificial intelligence solution today? It really only takes 2 things, very simple. First of which is data. You need a lot of data, the ability to collect gigantic amounts of data, and not just a lot of data, but data that actually covers the full scope of the problem that you're trying to solve. The good and the bad, all of the cases around it, the sausages and the drivers. You need to be able to cover the full scope of the problem that you're trying to solve. That's half of what you need. The other half is probably more current and may go away over time. Maybe in 50 years' time, we'll look again at this and we'll say, oh, why did we ever need that? But right now, we absolutely have to have expertise. And expertise comes into forms here, the first of which is expertise in using AI algorithms. If you don't have a person on your team that understands how to use AI algorithm, how to build the data sets, how to do the categorization, the learning process, you will not be successful. That is a reality today. It may go away in a few years when we have those smart self-teaching engines that will be able to do that. But right now, you need that expertise. And the other expertise that you also need that, again, may go away with those self-learning systems is domain expertise. Today, if you're looking to do image recognition, you have to have somebody in your team that understands what digital photography means. And the same goes for speech recognition. You need somebody that understands how the human language works and how the humans pronounce words. There's no way around it. And the same applies, by the way, to cybersecurity, which is the topics where I'm focusing most of my time. And let's talk a little bit now about the good part of cybersecurity and AI. So let's talk about how we use AI in cybersecurity. I'll try to be very brief about it because this is really not necessarily your concern, but we've mentioned that AI is being used in everywhere that you go. And the fact of the matter is that it's also being used in cybersecurity. If anyone has ever gone to a cybersecurity conference over the last 2 years, and I can only imagine none of you would because it's really boring unless you're actually working in this field, every single vendor out there would tell you their products are based on artificial intelligence. They're using AI and they're really, really smart, and now they're finally able to deliver something that no one else can because they're the only ones who know how to use AI in the right way. And some of them actually do. We do as well. I come from Checkpoint these days. We use AI in our products as well. Why do we use AI in cybersecurity? Because it's allowing us to solve problems that we couldn't have solved before. And it's not because they weren't solvable, but because it required too many resources to make it into a viable product that you can make in a reasonable cost. The first thing that it solves is automation. Rather than hiring 10, 100, 1,000, 10,000 human analysts and training them on what they need to do in order to deliver this, thank you. Thank you. Getting better and better. I just now need to fall completely flat on the stage and that will be perfect. I'll consider that as my exit. Anyway, so okay, so automation. I cannot hire enough skilled people on the cybersecurity front. There's just no way to hire them. There aren't enough skilled individuals in the world today that know what they're doing in cybersecurity. This is the truth of the matter, and the needs are just growing and growing and growing, and there's no way to hire enough. If I'm able to automate things that would otherwise require a human being, I've just made possible a problem that otherwise there's no way for me to solve in the right way. Automation is one part of it. The other part of it is scale. Our human brains are only capable of a certain scale. So we can take a problem and using our intuition to take into consideration 10, 20, 30, hundreds of different parameters and reach a conclusion. But that's the extent of it. We couldn't possibly, as human beings, process hundreds of thousands of different parameters. We simply cannot. So we would disregard parameter number, I don't know, 98,708. We will completely disregard it. But if we have a machine that is capable of this scale, we can deliver much better results. So that's the other part that we're getting with artificial intelligence, being able to take a lot more into consideration before we reach a verdict. And the third thing is speed. Cybersecurity is anything but slow. The changes are on a daily basis. Yesterday's threats are not today's threats, and they're not tomorrow's threats. You absolutely have to be on top of it, and only if you automate at the right scale can you reach the level of speed that is necessary to protect against actual threats. And all of this we are capable of achieving with AI algorithm in cybersecurity. So this is the great side. I'm not going to tell you about the problems and the difficulties that we're facing, because there's a lot of them. Let's just assume that this is perfect and this works. And let's take it now to the flip side of things, which is cybersecurity in artificial intelligence. So we talked about how artificial intelligence is really all around us everywhere, but have we ever given even any thought to using cybersecurity in artificial intelligence, to applying cybersecurity there? And the fact of the matter is that we're entering an era with cybersecurity risks like never before. As an industry, we're familiar with the type of threats that are prevalent all around us today. We see how malware is being introduced, we see fileless malware, we see attacks on the network, we see vulnerabilities, we know how to deal with that. These are the kind of risks that we've never seen before. If somebody is able to poison the data through which the algorithm was learning something, he can have very, very lasting implication on how this algorithm will work for years to come. And it's very difficult to go back and clean it. These are the type of risks that we're now facing. And if you think about the potential, for example, like I said, an algorithm determines my premium for insurance. If I can influence that algorithm, I may end up paying less. So there is huge motivation to influence that and to poison the data in such a way that would benefit me. And that's just the tip of the iceberg, of course, because if I wanted to modify, to cause damage to how your autonomous car drives, and it could actually lead to your death, right? So the risks are immense. Can we do anything? There are some things that we can do. So we talked before, the people sitting in this living room before said we need our governments to support us, not to regulate us. And that is true, but we also have a responsibility to do something that hasn't always been done when new technologies were being introduced. Very often, well, I want to split this statement, we don't have the luxury of being careless as we have in the past. Well, very often, when new technology were being introduced, security was not taken into consideration at all. So it was only put together, put on top of it later as an afterthought. If we understand the potential ramification today, we can demand the people that are developing artificial intelligence to put security precautions into their algorithm from the get-go. Not as an afterthought, but something that you build into your product, your devices, your algorithm from day one. And that has always been more effective. And the last thing I will say, because they want me to get off the stage, the very, very last thing I will say is that since the dawn of time, security has always had to come in layers. So we don't just have an air force, we also build shelters. And the same applies to cybersecurity. You need to build independent layers of security, and that's the only way to ensure that if one system breaks, the other one protects it, and the third one monitors it, and the fourth one gives you another indication if something seems to be off. That's the only approach that would be viable, along with requesting and requiring these algorithms to better explain themselves to the human being ultimately monitoring the results. That is my message to you this morning. Thank you very much.